Last winter, I spent around $800 on pellets for the rocket mass heater. Considering I'm heating a 1,200 square foot greenhouse, that wasn't too bad. However, I'm always trying to come up with a way to save a few bucks. Even though we have a large supply of free cordwood, it's difficult to keep feeding the heater when I need long burns, thus the reason why I switched to pellets. We can get wood chips for free, but their inconsistent sizes make it nearly impossible to feed them through a hopper by gravity into the heater. My goal was to come up with a way to grind up the random sized chips into something with a more consistent shape. It would have been great to get a shredder, but it is a bit out of the budget, so this is what I've come up with. The Chiplet Maker. This design is based on two of my older projects that utilized a wood auger bit for moving material under force, the plastic extruder and automatic fish feeder. The auger assembly is made up of a standard 1-inch wood auger bit. There's a brass bushing to get the shaft to fit into a 3/4 inch bearing. I cut the tip off the auger so that it could fit into this adapter. Usually I don't like to do custom machining on my projects, but I needed a good solid support for the auger, so I traded a friend a bunch of lettuce for some custom machining on his large lathe. I figured the auger will wear out far quicker than the other pieces, and I wanted to minimize the customization for this piece. The adapter has a couple of set screws to hold the auger in place. I then did some finish work on my small lathe. There's a thrust bearing, and then the adapter fits into another bearing. The assembly mounts to this frame, so we'll flip it over and mount it from the bottom. First, I'll attach the custom adapter to the auger and tighten the set screws. Then slide the thrust bearing onto the adapter. There's a plate that has a 1-inch hole drilled through it, which is the same diameter as the auger, which will hang loose for now. This plate is used as a backing and allows the auger to shear off the chips when they press against it. The assembly passes through a bracket where the thrust bearing can push against the bracket. If this wasn't there, the force against the auger would push the entire assembly backwards out of the bearings. The first bearing is attached, and then the second with the brass bushing on the other side. All the bearings are then bolted to the frame. Flipping the unit upright again, the cutting plate is attached to the frame. Once the bearings are adjusted and tightened, the cutter plate can be adjusted and tightened to fit properly against the auger. The auger assembly is then able to turn freely in the frame. A piece of expanded steel is used as a screen. It is attached to the frame with 8 carriage bolts that I modified the heads so they could grab into the screen and pull it tight against the auger bit. This helps to create a scissor action as the chips get caught between the screen and auger and shear them into smaller pieces. The drive assembly uses a bunch of parts from an old bicycle and a windshield wiper motor. One of the nice things about the bicycle parts is that you can play with the gear ratios and make sure the motor doesn't work too hard. I didn't bother installing a tensioning gear, so if I change the speeds, I usually need to change the length of the chain. Some quick, less than safe wiring back to the solar batteries, and it's up and running. The last feature is to add some legs, which really shouldn't be plastic pipe, and a hopper to add some storage capacity. After running it for a few hours, I did burn out the windings on my first motor, so I installed a sophisticated cooling system, which works surprisingly well. I also decided to add a safety feature. The system operates by the auger turning and dragging chips over the screen. As they move across the screen, some of them get trapped in it and get sheared apart and pieces fall through. Some of the chips make their way over to the cutting plate, where they get pinched into the plate and broken apart. The final product is a smaller and more uniform chip that should feed better into the rocket mass heater, reducing the risk of jamming in the hopper. I've made a few prototypes and should have something ready in a few months. I'll leave you with some footage of the machine operating along with an outtake. As usual, thanks for watching and your support, and we'll see you soon. I can't remember how to put it together.